Usually when we talk about a medical diagnosis, there's this expectation of precision.
Right,
Like,
absolutely.
it feels like an engineering problem. You break your arm, you go to the hospital, and the doctor puts you in front of an X-ray machine.
Right.
And when that film comes back, there is this stark, jagged white line across the bone.
It's undeniable.
Exactly. The doctor just points at it and says, there it is, that's the break. It's incredibly binary.
It is comforting in a way. I mean, we have this deeply ingrained psychological preference for things that are visible,
Yeah.
tangible things,
Yeah.
easily categorized, broken or not broken. It's a localized physical object that you can literally just point a finger at.
Totally. But then you step out of orthopedics and into the world of, say, neurodevelopment or complex trauma.
Oh, yeah. That's a whole different ballgame.
Right. Suddenly, that comforting X-ray machine is completely useless. You're looking at a diagnostic landscape that is just entirely murky.
You're trying to measure invisible forces, really.
Exactly. Behavioral resonances, systemic intersections. You transition from this comforting certainty of a physical thing to a state of, complete conceptual vertigo.
And you realize that the tools you use to find the broken bone are just fundamentally the wrong tools for understanding the system as a whole. You have to learn an entirely new way of seeing.
Yes, and what is absolutely wild to me is that this exact same feeling, that jarring transition from wanting to see a tangible thing to realizing reality, is so much more complex. It happens in physics, too.
It really does, at the highest levels.
Especially when you start asking the biggest possible questions about what reality actually is at its core. So today, we are taking you on a journey that might just honestly break your internal X-ray machine for how you view the universe.
That's definitely a paradigm shifter.
We are looking at a deeply mind-bending premise. What if the most famous particle in modern physics, the Higgs boson, the so-called God particle, isn't actually a particle at all?
Right.
What if, instead of being a little physical ball of stuff, it is simply a geometric inevitability?
Which, I mean, that requires a radical shift in perspective. In standard classical physics, we have been explicitly trained to look for that jagged line on the X-ray.
We want the physical evidence.
Exactly. We want to smash things apart and look for the smallest possible piece of rubble. But the source material we are diving into today asks us to just stop looking for the thing and start looking at the invisible geometric scaffolding that forces the thing into existence.
Right. So to guide you through this, we have a really fascinating stack of material on the table today. We are looking at a dense, incredibly provocative theoretical physics text by George James Dukas.
It's quite the read.
Oh, it's intense. It's dated exactly around our current time, June 2026, and it's titled Higgs Mass in TDUFT. And TDUFT stands for Transdimensional Unified Field Theory.
The mission here, for you listening, is to really decode this alternative framework of the cosmos. We are going to explore how TDUFT claims that everything, literally the matter making up the device you are listening on, the air you are breathing, your own body, it all emerges from a single, infinite, recursive, fractal field.
A field governed by something as elegant and honestly ancient as the golden ratio.
Exactly. We will unpack how this theory entirely redefines the speed of light, how it explains the origin of mass without using those arbitrary plugged-in parameters that just plague modern physics, and how it fundamentally reshapes our understanding of the fabric of reality.
Okay, let's unpack this, because I think we need to start by understanding why this is even necessary, right?
Yeah, that's a good place to start.
If you read popular science articles, you'd think physics has it all figured out. We have the standard model, so why write a whole new theory of the universe? What is fundamentally broken about our current understanding that requires a transdimensional unified field theory to fix it?
Well, to understand the true value of Dukas's work, we really have to talk about the awkward secrets of the standard model of particle physics.
The skeletons in the closet.
Right. Now, don't get me wrong. The standard model is arguably the most successful scientific theory humanity has ever constructed. I mean, it explains electromagnetism, the strong nuclear force, the weak nuclear force.
It's the gold standard.
It predicted the existence of quarks and gluons with just staggering precision. But it has a glaring, almost embarrassing quirk when it comes to the origin of mass.
The Higgs mechanism.
Precisely. Back in the 1960s, physicists like Peter Higgs realized that the math of the standard model predicted that fundamental particles should have no mass at all.
Wait, none?
None. They should all just be zipping around at the speed of light. But clearly, things have mass. You and I have mass.
Yep.
So they theorized this invisible field permeating all of space, the Higgs field.
Okay.
Particles wade through this field, and the drag they experience is what we perceive as mass. And to prove this field exists, there had to be a particle associated with it, which is the Higgs boson.
But the standard model had a massive blind spot regarding this particle, right?
Oh, a massive blind spot. The mathematics of the standard model told us how the Higgs boson should interact with other particles.
Yeah.
How it should decay, what its quantum spin should be. But the math absolutely refused to tell us what the mass of the Higgs itself should be.
It just left it out.
It was literally just a blank space in the equations. It could have been as light as an electron or as heavy as a Planck mass, which would be trillions of times heavier.
God, it's like a fill-in-the-blank question on a final exam where the teacher entirely forgot to give you the word bank, and the answer could be literally any word in the dictionary.
That is the exact anxiety the physics community lived with for decades.
Decades.
Yeah. So what did they do? They decided they couldn't solve it with pure math, so they had to solve it with brute force.
Right, the Large Hadron Collider.
Exactly. They built the LHC under the Swiss-French border. It's a 27-kilometer ring of superconducting magnets designed to accelerate protons to 99.9999991% the speed of light and just smash them into each other.
The ultimate multi-billion-dollar X-ray machine, just breaking things apart to see what falls out.
And in 2012, they found it. Sifting through the subatomic debris of trillions of collisions, they found a resonance peak at exactly 125 giga-electron volts, or GeV.
And GeV is just the unit they use for mass energy,
That's
right?
exactly. It's just standard particle physics terminology.
Yeah.
So the community celebrated. Nobel Prizes were awarded. But here is the crucial, somewhat unsettling part.
Okay.
They took that number, 125 GeV, went back to their beautiful, elegant standard model equations, and just wrote it in by hand.
Wait, they just manually patched the code?
They manually patched it. It's what physicists call an arbitrary input or a free parameter.
Wow.
It is based entirely on experimental observation. We know what the mass is because we measured it, but the standard model cannot tell us why it is 125 GeV.
There's no why.
Right. There is no fundamental geometric or mathematical reason within the standard model that forces the Higgs to be that specific weight. It's just a random fact of our universe, like the fact that Earth happens to have one moon instead of two.
It's just a random number we have to accept. We measure it, we plug it in, we move on. But TDUFT, this theory, Bud Dukas, looks at that 125 GeV and says, no, the universe does not do random. The universe does not have free parameters.
A profoundly different approach, yes. In TDUFT, that mass, that 125 GeV, is not a random number you just measure and plug in. It is mathematically demanded by the underlying geometry of the universe itself.
Meaning it couldn't be anything else.
Exactly. The theory argues that if you truly understand the dimensional geometry of reality, you don't need a 27-kilometer collider to measure the mass. The fundamental mathematical laws of the universe will force the Higgs to be exactly 125 GeV. It cannot be 124. It cannot be 126.
Which is such an audacious claim. If true, it's like finding out that the size of a specific leaf on a specific oak tree isn't just a random result of biology and weather, but is perfectly mathematically dictated by the root system of the entire forest.
That's a great way to look at it.
But the text makes it incredibly clear that before we can even begin to understand mass, before we can talk about the Higgs or the LHC, we have to take a massive conceptual step back. We have to understand the thing that has zero mass. We have to understand light.
Right. You cannot understand mass in TDUFT without first rewriting classical electromagnetism. Mass is essentially the end product of a process that begins with light.
Okay, so we're going back to the 19th century.
We have to. We have to look at how we define the speed of light, moving from James Clerk Maxwell's classical equations to the geometry of the golden ratio.
Let's get into the weeds here, because this is where the theory first starts really pulling the rug out from under classical physics. For anyone who has taken a high school or college physics class, James Clerk Maxwell is an absolute legend.
Oh, undoubtedly.
In the 1860s, he took electricity and magnetism, which people thought were two completely different forces, and proved they were two sides of the same coin. He gave us the classical formula for the speed of light in a vacuum, which we all know as c.
Right. Maxwell's synthesis is one of the greatest intellectual achievements in human history, really. He derived this beautifully simple empirical relation for the speed of light. He found that c equals 1 divided by the square root of the product of two constants. Vacuum permeability, represented by the Greek letter mu naught, and vacuum permittivity, represented by epsilon naught.
Let's pause and define those constants because they sound incredibly jargon heavy.
Yeah, they do. Simply put, vacuum permittivity epsilon naught is a measure of how much resistance a vacuum offers to the formation of an electric field.
Okay, resistance to an electric field.
And vacuum permeability mu naught is the equivalent for a magnetic field. Think of them as the electrical and magnetic thickness or stiffness of empty space.
Right, that makes sense.
Maxwell realized that light is just an electromagnetic wave propagating through space, so its speed must be entirely determined by the stiffness of that space.
And people had actually measured these constants in laboratories, right, with capacitors and coils and stuff.
Exactly. Long before Maxwell unified them, scientists had measured these values empirically.
Yeah.
When Maxwell plugged those laboratory measurements into his new equation 1 over the square root of mu naught times epsilon naught, the number that popped out was roughly 300,000 kilometers per second.
Which perfectly matched the measured speed of light.
It perfectly matched. It was a complete revelation.
But the text by Dukas points out something very, very specific about these two constants when you look at them in standard metric units. When you multiply mu naught and epsilon naught together, the result equals roughly 1 over 9 times 10 to the 16th power.
And this is where Dukas starts pulling at the loose threads of modern physics.
Yeah.
In classical physics, that factor of 9 and the 9 times 10 to the 16th is just treated as a random empirical artifact.
Yeah.
It's just a byproduct of how humans decided to define the meter and the second.
It's just a coincidence of our measurement system.
Right? We measured the speed of light, we worked backward from the constants, and that 9 popped out. It has absolutely no deeper philosophical, mathematical, or geometric meaning in the standard model. It's just a number on a chalkboard.
But Dukas looks at that 9 and essentially says, wait a minute, the universe doesn't do random integers. He reimagines velocity entirely. He argues that the fundamental speed limit of the universe isn't based on arbitrary human meters and seconds. It's based on the golden ratio operator.
What's fascinating here is the introduction of phi, the golden ratio. Now, phi is approximately 1.618.
Right, we see it everywhere.
Everywhere. It's a number that has captivated mathematicians, artists, biologists for centuries. You see it in the spiral of a nautilus shell, the arrangement of seeds in a sunflower, the arms of spiral galaxies. It defines optimal packing and harmonic scaling in nature.
But in physics.
In modern theoretical physics, phi is generally ignored. It's seen as a biological curiosity, or like an aesthetic rule of thumb, not a fundamental constant of reality like pi or e. TDUFT claims this is a massive oversight. TDUFT claims phi isn't just a pretty pattern, it is the fundamental algorithmic operator of spacetime.
And so the text provides a brand new formula for the speed of light derived entirely from the golden ratio, and it is a wildly different way of looking at reality.
It really is.
It says C equals the quantity of 2 plus phi to the negative 1 power plus phi to the negative 2 power minus epsilon, and all of that is multiplied by 10 to the 8th power.
Let's break that down, because it looks incredibly complex at first glance, but it actually contains a breathtaking, almost poetic mathematical simplicity.
Okay, lay it on me.
Focus purely on the phi terms inside the parentheses. So phi to the negative 1 plus phi to the negative 2.
So that's basically 1 over phi plus 1 over phi squared.
Exactly. Now let's do the math conceptually. Phi is roughly 1.618. If you calculate 1 divided by 1.618, you get approximately 0.618.
Right.
If you calculate 1 divided by 1.618 squared, you get approximately 0.382.
And if you add 0.618 and 0.382,
Yeah.
you get exactly 1.000.
You get exactly 1. And this isn't an approximation. It is a fundamental, unique algebraic property of the golden ratio. Phi is literally the only positive number in existence where its square is equal to itself plus 1.
Wow.
Which also means its inverse plus its inverse square equals exactly 1.
It's perfectly self-referential.
It is perfectly recursive. So let's go back to Dukas's formula. Inside the parentheses, you have 2 plus that phi section. Since the phi section evaluates to exactly 1, the entire core of the equation simplifies to 2 plus 1.
Which is 3. The text calls this the Trinitarian sum.
The Trinitarian sum.
Yeah.
The baseline speed of light operation in TDUFT is fundamentally rooted in this clean, geometrically derived integer of 3.
Okay.
Now hold that 3 in your mind, and let's jump back to Maxwell's classical empirical equation. Remember that seemingly random factor of 9 that we get when we multiply vacuum permittivity and permeability.
3 squared is 9. Oh my god. The 9 wasn't random at all.
The empirical 9 in Maxwell's equation, which generations of brilliant physicists have treated as a totally meaningless artifact of human measurement for over 150 years. It is actually the square of the TDUFT Trinitarian sum. It's the square of the golden ratio operation.
I really want to make sure you, the listener, feel the weight of this paradigm shift, because when I read this part of the text, I literally had to put the paper down and walk around the room.
It's a huge moment.
Think of it like reverse engineering a chaotic family recipe. Imagine for generations your family has been making this incredibly complex, perfect cake, and the recipe just says, add exactly 9 cups of flour.
Right, and you just do it.
For years, nobody questions it. You just accept that you add 9 cups because that's what the measuring cup says, and the cake always turns out great. You assume it's just an empirical fact of
Or
baking.
free parameter of the kitchen.
Exactly. But then Dukas comes along, looks at the recipe, looks at the kitchen, and realizes that the 9 isn't a random amount of flour. It's actually 3 squared. And that 3 comes from the exact geometric dimensions of the baking pan itself. It's a 3 by 3 grid.
That is a phenomenal analogy.
Right. The amount of flour was never arbitrary. It was geometrically demanded by the spatial structure you were pouring it into.
The 9 in Maxwell's equation was always just a shadow cast by the underlying golden ratio geometry. We were measuring the shadow and just completely ignoring the object casting it.
Unbelievable.
But to be mathematically rigorous, we do have to address the rest of the TDUFT formula. Because the core gives us exactly 3 times 10 to the 8th meters per second, which is 300 mils in meters per second flat.
Right, but we know from precise laser measurements that the actual speed of light in a vacuum isn't perfectly 300 million. It's 299,792,458 meters per second.
Exactly. So there's that little tiny piece at the end of the parentheses, the minus epsilon. The universe shaves a little bit off the top.
The tiny attenuation factor. In the text, epsilon is approximately 0.000207. Now, in standard physics, when a theorist is close to an answer but not quite there, they might just invent a fudge factor to make the math match reality.
Yeah, that happens a lot.
But TDUFT doesn't do that. Dukas derives this epsilon completely independently using something called the Ramanujan-Rogers continued fraction.
Yes.
Let's explain what a continued fraction is, because that honestly sounds like advanced calculus terrorism.
It does sound intimidating, yeah, but conceptually, it's just a nested Russian doll of mathematics.
Okay, nested dolls.
Imagine a fraction where the denominator contains another fraction, and the denominator of that fraction contains another one, going on infinitely. The Ramanujan-Rogers continued fraction is a highly specific, infinite mathematical structure that is deeply tied to, you guessed it, the golden ratio.
So why does this infinite fraction reduce the speed of light?
Well, think of it as the mathematical representation of fractal friction.
Fractal friction.
Okay. The Trinitarian sum, the 3, represents the ideal, perfect geometric potential for the speed of light. But the universe isn't just one flat layer of math. According to TDUFT, it's an infinite, recursive, fractal lattice.
So it's bumpy down there.
Exactly. As light propagates through reality, it has to traverse these infinite microscopic dimensional layers. The Ramanujan-Rogers continued fraction calculates the exact drag or attenuation caused by dragging a wave through an infinite fractal structure.
Wow.
It pulls the clean geometric 3 down to the exact, messy, real-world measured speed of light. It's not a fudge factor, it's a structural necessity of a fractal universe.
So we have this beautifully precise equation that builds the speed of light out of the golden ratio and fractal friction. But the text pushes even further into what these numbers actually mean dimensionally. Like, it's not just algebra on a page. Every number represents a physical dimensional state.
What's fascinating here is the dimensional breakdown of that Trinitarian sum. Remember, it was 2 plus 1. The 2 in that equation represents the 2D baseline of reality. Think of it as a perfectly flat, two-dimensional plane, like a sheet of paper with absolutely zero thickness. In TDUFT, this is the domain of the massless photon. Light, fundamentally, operates as a 2D wavefront propagating through the lattice.
It has length and width, but no depth.
Exactly.
Therefore, it can have no volume. And if it has no volume, it can have no mass.
Precisely. Light is massless because it is trapped in 2 dimensions.
Yeah.
But then you have the +1 in the equation, which comes from the phi inverse plus phi inverse squared harmonic. That +1 is the harmonic increment.
The harmonic increment.
Think of it as a geometric pressure. It is an evolutionary force built into the golden ratio that pushes upward against that flat 2D plane, trying to lift it into a 3-dimensional structure.
It's like the universe is trying to build depth.
The Trinitarian sum of 3 marks the exact dimensional boundary line. It is the transition point where 2D is pushed to its absolute limit and is forced to pop out into 3D space.
which provides the most incredible logical bridge to the core of this entire theory. Because if light exists purely on this flat 2D plane, what the text calls d squared, how do we get stuff?
Right.
How do we get from a flat, massless universe of light to a heavy, three-dimensional universe of mass? How do we construct the screen you are looking at, the chair you are sitting in, or the cells in your body?
This is where TDUFT introduces its fundamental dimensional identity. It is a beautifully compact, deceptively simple equation. M equals d cubed times t squared.
Mass equals d to the third power times t to the second power. And the
Yeah.
text specifies that t here is a time operator directly related to the golden ratio. T equals -1/5. It's a geometric time operator, which we'll get to in a moment.
Yeah.
But I really want to focus on the d part.
The m equals d cubed component is the physical mechanism for existence. In the standard model, we tend to think of mass as a substance, like water being poured into a glass.
Right, stuff inside a container.
We think particles are these tiny solid grains of sand that possess this magical property called mass, and they sit inside the empty container of 3D space.
But TDUFT says the container is the mass.
Let me reframe that slightly. TDUFT argues that mass is geometry. Mass appears when a planar 2D photon-like wavefront, that flat sheet of paper, the d-squared state, is subjected to that +1 harmonic pressure and achieves what the text calls volumetric closure.
It folds perfectly to enclose a space.
Yes, it becomes 3D.
The d-cubed state.
Yes, it is the d squared to d cubed dimensional transition. When the 2D plane folds upon itself to create a closed volume, it snaps from being a massless wave of light to being a 3D point of mass. Matter is quite literally made of confined, structurally folded light.
And here's the big reveal. This is the absolute core of the text regarding the Higgs, and it completely shatters the standard model paradigm.
It does.
In standard physics, as we discussed, the Higgs boson is this fundamental particle, a little speck that wades through a field and interacts with other specks to give them mass. But TDUFT says the 125 GeV resonance that we call the Higgs boson is not a standalone scalar particle at all.
No, it's not.
It is not a marble. It is simply the dimensional resonance peak of this exact closure event. It is the doorway, the gate, the audible snap of 2D light folding into 3D math.
Exactly.
But I really need to push back on this, or at least have you deeply clarify it, because my brain, and I'm sure the listener's brain, is still completely stuck in particle mode.
It's hard to shake.
All of our science communication is based on particles. What is the actual physical difference between a particle and a resonance peak? Because when I hear they found the Higgs at the Large Hadron Collider in 2012, I literally picture scientists sifting through subatomic rubble and finding a distinct, shiny little marble that they hadn't seen before.
Right.
But you're telling me we need to throw the marble metaphor in the trash?
The marble metaphor is worse than useless here. It actively prevents you from understanding reality, according to this text. We need an entirely different physical intuition.
Okay.
Let's use an analogy that relies on geometry. Let's talk about origami.
Okay, I love this. Let's say the universe is an incredibly complex origami project.
In the standard model, physicists treat the Higgs boson like a specific, rare, magical type of paper. They look at all the folds of the universe, the electrons, the quarks, and they say, to give these other pieces of paper mass, we need to introduce this special Higgs paper that interacts with them.
Right.
TDUFT treats the universe entirely differently. In TDUFT, there's only one kind of paper in existence, the 2D light plane, the photon layer. The Higgs isn't a new piece of paper you add to the pile. The Higgs is the crease.
The crease, the actual act of folding.
It is the exact moment, the geometric stress point, where that flat piece of paper is perfectly folded to create a 3D box. The mass is the resulting box. The Higgs is the energy of the folding event itself.
That is incredible. But wait, if it's just a folding event, why do scientists at the LHC look at their computer screens and say, we found a particle? Why did they give it a name like a physical object?
Well, because you have to remember how incredibly indirect particle physics actually is. At the LHC, we don't have microscopes that can see little spheres. We don't see particles. We smash protons together at unimaginable energies.
Right.
The protons shatter into pure energy, and that energy instantly recoagulates into new dimensional configurations that decay almost immediately. We don't see the configurations. We only detect the decay products.
Just the aftermath.
Exactly. We see flashes of light hitting calorimeters. We see curved trails of ionization in massive magnetic fields. Then supercomputers take all those trails and flashes and work backward to reconstruct what happened the billionth of a second after the crash.
They're trying to figure out what exploded based on where the shrapnel landed.
Precisely. And what they actually see on their data charts is a spike on a graph, a peak in what they call invariant mass distributions. They look at billions of collisions, and they notice a massive pileup of data exactly at 125 GeV.
Okay.
Standard physics looks at that spike, calls it a particle, names it the Higgs boson, and assigns it a lifetime, even though it disappears in a fraction of a microsecond.
Right.
TDUFT looks at that exact same data and says, no, that spike is the acoustic signature of the D lattice snapping into volumetric closure. You aren't seeing a particle. You are hearing the mathematical click of the 2D plane locking into a 3D volume. You are measuring the energy required to make the crease in the origami.
Which implies that the Higgs isn't an isolated floating entity with an assigned lifespan. It's an event,
Yep.
a localized dimensional closure event within the fractal field.
Exactly.
But this theory to hold water, for this origami geometry to be taken seriously by the scientific community, the math has to actually yield that exact number, 125 GeV.
Right, you need the math to back it up.
You can't just have a gorgeous, poetic origami metaphor. The equations have to hit the experimental target dead center. And this brings us to a part of the text that absolutely melted my brain. Because to calculate that 125 GeV mass, TDUFT provides two different mathematical equations, and they introduce a completely wild discrepancy in the concept of time.
This is where the theory gets extremely rigorous, and it demands that we just abandon our macroscopic intuition about how time functions.
Yeah.
To prove that the Higgs resonance is a geometric certainty, Dukas presents two different operator forms to calculate the mass. Let's look at equation 1, what the text formally calls the bridging form.
This is the equation that connects the Maxwell speed of light revision we talked about earlier directly to the generation of mass. It's written out as lowercase m equals c times g times t, all divided by d squared.
Yes.
So c is the speed of light, g is the universal gravitational constant, t is time, and d squared is that 2D dimensional plane.
Right. So when you take the target mass of 125 eV, plug it into that equation, and solve algebraically, fourth the time, you get a result of 4.7175 times 10 to the negative 23 seconds.
Which is an infinitesimally small slice of time. That's a decimal point followed by 22 zeros, then a 4.
It is incredibly brief. But here's the critical point. In the realm of high-energy particle physics, it is entirely rational. This timescale makes perfect physical sense.
Okay, how so?
Well, it matches the high-energy interaction and formation times seen in real-world collisions at the Large Hadron Collider. When you smash protons together at near light speed, the fundamental interactions, the creation and decay of these resonance states, they happen on the scale of 10 to the negative 23 or negative 24 seconds.
Oh, wow.
It's roughly the time it takes light to cross the width of a single proton. It's a timescale that maps comfortably onto our physical experimental observations of the Higgs peak.
Okay, so equation 1, the bridging form, gives us a number that makes sense to our current experimental science. It feels grounded. But then Dukas introduces equation 2, the compact variant.
The compact variant is conceptually much cleaner, mathematically more elegant, but numerically, it is deeply shocking.
It is.
It states that capital M equals c cubed times capital T, all divided by g.
It looks simple. But when you take this equation, plug in the 125 GeV mass, and solve for this new capital T time, the result is absurd. The text states that T equals 5.5198 times 10 to the negative 61 seconds.
10 to the negative 61.
Yeah.
To truly understand how profoundly small that number is, we have to compare it to the absolute limit of modern physics, which is the Planck time.
Right.
In standard quantum mechanics and relativity, the Planck time, which is roughly 10 to the negative 44 seconds, is considered the absolute smallest measurable unit of time. It is the hard limit of reality.
It's like the pixel size of the universe.
Exactly. If you try to zoom in past a pixel on a photograph, there is no more image there. There is no deeper resolution.
Yeah.
Just the underlying code of the file.
Right.
In physics, if you try to measure a duration shorter than the Planck time, classical spacetime completely breaks down. The fabric of reality is so tightly woven at that scale that the concepts of before and after lose all physical meaning. You literally can't have a sequence of events.
Right. And this is where I have to stop and push back hard. If Planck time is the pixel size of the universe, how can we possibly have a time scale with 17 more zeros?
That's impossible.
10 to the negative 61 is a fraction of a fraction of a fraction of the Planck time. It feels like TDUFT just violently broke its own physical rules. If you cannot have a measurable duration shorter than a Planck pixel, what on earth is this number actually measuring? Because it cannot be a duration you'd measure with a physical subatomic stopwatch.
It's an excellent pushback. And it's the exact hurdle theoretical physicists face when reading this text. But the text is very explicit about this distinction. This extremely small capital T is not the experimental peak time we see in colliders, and it is not a physical lifetime of a particle.
Okay.
It does not correspond to any directly measurable duration in a physical space.
Then what is it? If it's not time as we experience it, what is it?
It's an operator time. Let's build on your pixel analogy and use a software engineering metaphor to make sense of the sub-Planckian scale.
I like it.
Think about a high-end computer game. When you play a game, the fastest thing you can physically perceive on the screen is the frame rate. Let's say the game is locked at 60 frames per second. If an animation or an event happens between those frames, it doesn't exist to you as a player.
Yep.
It is fundamentally unobservable.
Right, you can't see it.
That frame rate, the 60 FPS, is like the Planck time. It is the absolute limit of the observable, rendered reality.
Okay, I follow that. Space-time is the monitor. The Planck time is the 60 FPS refresh rate.
But underneath the graphics, hidden from the player, running the entire show, is the processor clock. The CPU is executing billions of calculations, matrix multiplications, and physics engine updates between every single visual frame just to determine where the polygon should go and how the light should bounce. The TDUFT timescale of 10 to the negative 61 seconds is like the clock speed of the universe's background CPU. It represents the deepest recursion layer of the golden ratio operator engine.
Oh, wow.
It is the geometric time it takes for the mathematical algorithms of the universe to execute, not a physical lifespan of a particle rendered on the screen.
So it's not a duration in space-time, it's the hidden refresh rate of the geometric calculation creating space-time. The math requires that tiny microscopic scaling parameter to mathematically balance the incredibly massive key cubed and the incredibly small gravitational constant g.
It's a structural necessity, yes.
Yeah.
The dimensional weighting of this compact form is extreme. You're cubing the speed of light. So T's nu must be extraordinarily small to compensate and yield a relatively small mass like 125 GeV.
Right.
But mathematically, within the fractal field, it is perfectly consistent. And this leads to the most crucial unifying point in this section of the text, the concept of full coupling.
Right, because a skeptic would look at this and say, you have two different equations that yield two wildly different times for the exact same Higgs mass. That's a contradiction, your theory is flawed. But Dukas argues this isn't a bug, it's the ultimate feature.
Exactly. At full volumetric closure, the precise moment when that origami paper is perfectly tightly folded into a complete 3D box, these two mathematical expressions are forced by geometry to converge.
Okay.
The fundamental identity, d cubed times t squared, must equal the compact variant, c cubed times t divided by g. When the golden ratio harmonic lift is maximized and the closure is 100% complete, all the operators, from the macro to the sub-Planckian, lock into the exact same value.
And that unified value is exactly 125 GeV.
Yes. The 10 to the negative 23 seconds lives at the closure layer, the tangible boundary where geometry becomes mass, the part we can almost see in our LAC colliders. The 10 to the negative 61 seconds lives at the deep, hidden recursion layer, the sub-Planck math engine, crunching the golden ratio. But they are not contradicting each other. They are describing the exact same full coupling event from two different depths of reality.
So we have this golden ratio geometry operating at a sub-Planck level, acting like the hidden CPU code of the universe to calculate and create mass out of flat light. This naturally leads to the next massive question, because if this recursion engine is creating mass down at that deep foundational level, does it affect the rest of the universe? Like, are other fundamental forces running on the same code?
The answer is an emphatic yes. It doesn't just affect the rest of the universe, it runs everything. The text introduces what Dukas calls the universe master equation, which acts as the top-level recursion engine of reality.
Now, I'm going to spare you, the listener, and I am not going to read the actual calculus formula for the master equation out loud because it involves a truly terrifying number of Greek letters, partial derivatives, infinite series, and summation symbols.
It's definitely not radio-friendly.
No, not at all. But I want to describe its ingredients because the components of this equation are what matter. The master equation is built out of gamma functions, phi-powered harmonics, d-ladder recursions, and zero-point damping.
What is vital for you to understand isn't the specific calculus integration, but the architectural structure of the equation.
Yeah.
The text points out a profound, almost spiritual revelation in the math. The master equation shares the exact same operator skeleton as the speed of light clause we talked about earlier, and the rules for mass emergence, and the equations governing the strong nuclear force that holds atoms together.
Let me use a catchphrase here to center us. So what does this all mean? Let's use our software analogy again. Imagine you have a computer. The speed of light is one specific application running on the computer.
Good.
The strong nuclear force, the glue holding the center of protons and neutrons together, is an entirely different app. And mass generation, the Higgs mechanism, is a third app. Before TDUFT, standard physics essentially believed these apps were made by completely different developers using different coding languages.
Right, they were siloed.
Quantum mechanics wrote one app, general relativity wrote another, and for a century, physicists have been pulling their hair out because they couldn't get these apps to talk to each other perfectly.
The great crisis of modern physics.
Yeah.
The incompatibility of the macro and the micro.
Exactly. But what Dukas is showing us with this master equation is that if you hack into the system and look at the source code of all these seemingly different apps, they are identical. They're all running on the exact same root operating system, the exact same BIOS or kernel.
And that root code is the golden ratio of phi harmonic recursion.
It's beautiful.
If we connect this to the bigger picture, this is the holy grail of theoretical physics.
Huh?
True seamless unification. It links the speed of light laws directly to mass generation and strong sector quantum evolution in a single, unbroken chain of logic. The text explicitly states that the Higgs resonance, the d squared to d cubed volumetric gate, is not an isolated anomaly. It is not a special case patched in to fix a broken standard model. It is just one localized, inevitable step inside the universal recursion engine that drives all cosmic evolution.
And this master equation provides the answer to one of the most stressful mysteries about the Higgs mass. In standard physics, there are deep existential mathematical worries about why the Higgs mass is stable. It's called the hierarchy problem.
A huge headache for theorists.
Basically, if the Higgs field is interacting with all these incredibly heavy quantum fluctuations in the vacuum, its mass should theoretically skyrocket to the Planck scale. It should be trillions of times heavier than 125 GeV.
Right.
Physicists have had to invent entirely new, unproven theories like supersymmetry just to explain why the Higgs doesn't crush itself under its own quantum weight. Why is it reliably, stably 125 GeV?
TDUFT provides a beautifully clean, purely geometric answer to that, without needing to invent invisible, supersymmetric particles. The master equation explains why the mass is fundamentally stable. It is locked in place by what the text formally calls gamma-regulated d-ladder quantization.
Okay, let's unpack that term, because gamma-regulated d-ladder quantization is quite a mouthful.
It is, yeah. Let's take it piece by piece. The d-ladder refers to the dimensional ladder moving from 1D to 2D to 3D.
Okay.
Quantization means this movement happens in strict, discrete steps. You can't have 2.5 dimensions. You're either flat or you have volume.
Right, there's no in-between.
And the gamma regulators are based on the gamma function, which is a mathematical way of extending factorials to ensure a smooth, continuous, yet strictly bounded growth.
So because the folding of the origami paper from 2D to 3D is a rigid geometric process governed by the golden ratio and bounded by these gamma functions, it can't just casually inflate or shrink.
Precisely. It cannot be any arbitrary size. It has to happen in quantized, mathematically rigid steps enforced by the regulators in the master equation. The mass doesn't fluctuate wildly because the geometry of the dimensional ladder is absolutely rigid. It's like asking why a perfect triangle doesn't suddenly have 185 degrees inside it. It can't. The geometry forbids it.
Which is such a deeply satisfying answer. It's not stable by a lucky accident. It's stable because the foundational geometry of the universe dictates it.
Exactly.
But this concept of geometric rigidity brings us to a really tricky paradox, and this is where we dive into the final major concept of the text. Because if the universe is a structural lattice governed by this rigid, quantized geometry, what is the lattice actually made of?
That is the big question.
If it's rigid enough to keep mass stable and force light to obey the golden ratio, is the universe just a block of solid ice? Or is it fluid, like water, allowing planets and galaxies to move through it?
This is one of the most conceptually elegant yet challenging parts of TDUFT. Throughout the 19th century, physicists believed in the ether, a rigid, invisible fluid filling all of space that light waved through.
Right, the luminiferous ether.
Yes, Einstein's relativity largely abolished the ether, replacing it with the curved spacetime metric. Quantum mechanics replaced it with a boiling quantum foam of virtual particles. But TDUFT proposes something different.
Okay.
It posits that the vacuum of space is neither perfectly fluid nor rigidly solid. It is a semi-rigid elastic lattice. And it achieves this hybrid state by dividing the fabric of the universe into two distinct structural components, inelastic nodes and elastic strings.
Let's break those down, starting with the nodes.
The inelastic nodes are the fixed, rigid, dimensional anchors of the universe. Think of them as the immovable intersections on a 3D grid. They do not stretch, they do not deform, and they absolutely do not absorb strain. They're perfectly inelastic.
Because if the nodes themselves stretched, the geometry would fail. Mass would smear out, right?
Exactly. The absolute inelasticity of the nodes is what allows for stable mass, for the rigid quantization we just discussed, and for that exact volumetric closure. The node is the anchor that ensures the 125 GeV resonance is a sharp, specific peak and not a blurry smear of energy.
Okay, so the nodes are the hard, immovable anchors. What about the spaces between them? Because things clearly move. Light travels. Gravity bends space.
That is where the elastic strings come into play. These are the phi-psi connections, the energetic links spanning the gaps between the fixed nodes. And unlike the nodes, these strings are highly elastic.
So they can move.
They can bend, they can shear, they can twist, and they can carry torsion. They are the shock absorbers of reality. They absorb and transmit the strain of the universe.
So when a wave of electromagnetic light propagates across the galaxy, or when the heavy mass of a star bends the fabric of space around it to create gravity, it's not the grid points themselves moving.
No.
The points stay mathematically locked. It's the elastic strings connecting the points that are stretching, vibrating, and carrying the tension.
That's right. And the text doesn't just propose this as a metaphor. It provides the mathematical proof by calculating the vacuum's Poisson ratio.
Let's define the Poisson ratio for anyone who hasn't taken a materials engineering class, because it's a brilliant way to measure how stuff behaves.
Yeah, it's very useful here.
It is basically a measure of how a material deforms under stress. If you take a thick rubber band and pull it, it obviously gets longer in the direction you were pulling, but it also gets thinner in the middle.
Right, the lateral contraction.
That squeezing effect, that lateral contraction, is measured by the Poisson ratio. Cork, for example, has a Poisson ratio of almost 0. When you compress a cork to shove it into a wine bottle, it compresses down, but it doesn't bulge out the sides, which is why it fits in the neck of the bottle.
Perfect analogy.
Rubber, on the other hand, has a high ratio. It bulges violently.
It's a fundamental property of elasticity. In classical mechanics, a material's Poisson ratio can be determined by looking at the speed of different types of waves traveling through it. Specifically, it's determined by the ratio of the speed of longitudinal waves to the speed of transverse waves.
Okay, wave types. Imagine a slinky. A transverse wave is when you hold one end of the slinky and wiggle it up and down.
Right.
The wave moves forward, but the physical slinky material is moving up and down perpendicular to the direction of travel. That's how light works. Light is a transverse wave.
Correct. And a longitudinal wave is when you hold the slinky straight and push it forward quickly. You create a compressed ring of slinky that travels down the line. The movement of the wave is parallel to the direction of travel.
Like sound waves in the air.
Exactly. Sound waves are longitudinal. Now, TDUFT makes a profound assumption. It assumes that in the vacuum of space, the ratio of the longitudinal wave speed to the transverse wave speed is exactly the golden ratio, phi.
And when Dukas plugs the golden ratio into the standard engineering formula for the Poisson ratio, the text shows that you get a Poisson ratio for the vacuum of approximately 0.191.
Which is a very specific, relatively low number. It's mathematically perfectly consistent with a lattice that has fixed inelastic nodes that do not bulge or contract laterally, but is connected by strings that can carry the wave deformations. The fundamental geometry of the nodes remains completely intact, while the string connections absorb the kinetic energy.
But wait, we have to pause here. This brings up a massive, highly controversial question that just broke my brain again.
Okay, what is?
If the universe has transverse waves, which we know as electromagnetic light traveling at the speed of light, and longitudinal torsion waves that travel at the golden ratio times the transverse speed, does that mean there are waves traveling at 1.618 times the speed of light?
It mathematically implies a wave state propagating at phi times c.
Does this mean the speed of light varies? Have we just broken Einstein's theory of relativity? Because the central pillar of modern physics is that nothing, absolutely nothing, can travel faster than the speed of light in a vacuum.
This is a crucial distinction, and it's where theoretical physics requires intense nuance. The answer is no, we have not broken relativity, and the speed of light does not vary in the natural universe.
Oh, thank God.
The transverse wave, which is electromagnetic light, the stuff that bounces off our retinas, remains firmly and constantly at the speed of c. The longitudinal torsion wave, this deep geometric stress traveling through the elastic strings, does indeed travel at 1.618 times c, but, and this is the absolute key to preserving Einstein and causality, it does not transmit information.
It's a phase wave, a torsion mode in the D lattice.
Exactly. Think of sweeping a laser pointer across the surface of the moon. If you flick your wrist fast enough, the red dot on the moon will move across the lunar surface faster than the speed of light. But you can't use that dot to send a text message from one side of the moon to the other, because the information is traveling from your hand to the moon at the speed of light. The dot itself isn't a physical object transmitting data, it's a phase state.
I see.
Similarly, this longitudinal torsion wave cannot carry a signal. It cannot transmit mass or data. Because it cannot carry information, it does not violate causality. You cannot use the golden ratio torsion wave to set a message back in time or faster than light.
Okay, so under natural cosmic conditions, the vacuum's elastic symmetry is completely stable. The transverse speed is locked at c, the longitudinal background torsion speed is phi times c, and nothing breaks the speed limit of information. Relativity is safe.
Relativity is perfectly safe.
I hear the caveat there. Under natural cosmic conditions, I really want to probe the absolute limits of this elasticity idea. If the universe is an elastic medium connected by these strings, could we theoretically stretch it too far? Could the speed of light vary under extreme unnatural conditions?
That is where the theory shifts from explaining nature to opening a terrifying, fascinating loophole for engineering.
Okay.
Yes. If a sufficiently advanced technology, a Type 3 Kardashev civilization, perhaps we're to figure out how to inject massive, unimaginable amounts of targeted energy to artificially distort that phi torsion lattice.
Right.
If they could create a localized defect in the dimensional grid, they could theoretically alter the vacuum's effective elasticity.
Because if you change the tension of the strings, you change how fast a wave travels across them, just like tuning a guitar string changes the pitch.
Exactly. By fundamentally changing the tension of the medium, you would change the local speed of light. It's much like how light naturally slows down when it enters a glass prism or a pool of water because the atomic medium is denser.
But this wouldn't be shining light through glass.
No, this would be altering the fundamental dimensional medium of space-time itself. You wouldn't be violating relativity because c is defined by the vacuum. You would simply be operating in a newly engineered, non-natural vacuum where the speed limit has been artificially raised or lowered.
Which brings us to the absolute edge of this theory and really to the end of our deep dive today. Let's synthesize the massive amount of theoretical ground we've just traveled over.
It's been quite a journey.
We started with an X-ray machine looking for a solid particle, and we ended up in a golden ratio-powered origami universe. We've seen how Maxwell's classic equations were actually hiding a deeper geometric truth where the seemingly random factor of 9 was actually the Trinitarian sum of 3 squared.
Right.
We explored how the Higgs boson isn't a little marble of a particle at all, but the acoustic resonance peak of 2D light folding perfectly into 3D mass. We grappled with a sub-Planckian operator time of 10 to the negative 61 seconds that doesn't measure physical duration, but acts as the universe's background CPU clock.
Uniting everything.
Exactly. We saw how the master equation finally unites the speed of light, the strong nuclear force, and mass generation under one mathematical roof. And finally, we discovered that reality is a semi-rigid lattice composed of inelastic, immovable nodes and elastic, vibrating strings.
It is a breathtaking synthesis of physics, geometry, and information theory. The matter that makes up your body, the screen you are looking at right now, the air you are breathing, none of it is a collection of random subatomic billiard balls randomly assigned mass by arbitrary parameters.
Not according to this.
According to TDUFT, you are made of localized resonance peaks.
Yeah.
You are intricate, perfectly balanced geometric origami folded from the fabric of light itself, governed continuously at every scale by the golden ratio.
But before we let you go, we want to leave you with one final, slightly unsettling thought based on that engineering loophole we just discussed.
This raises an important question regarding the limits of reality.
Yeah.
We talk about how an incredibly advanced technology might artificially stress the elastic strings of the universe to alter the tension of the vacuum and change the speed of light. But we also established that the inelastic nodes are the rigid anchors that hold 3D mass together, allowing volumetric closure to exist.
So, if humanity or anyone else out there in the cosmos ever figures out how to manipulate this underlying code, if we pull the fabric of reality too hard, if we stretch the elastic strings past their natural tolerance limit, Do we just change the speed of light?
Or do we accidentally break the inelastic nodes?
If we pull the crease out of the origami too forcefully, do we accidentally unfold the d-cubed geometry of mass, dissolving our solid matter, our planets, our bodies, back into pure, flat, massless 2D light?
It's the ultimate diagnostic muddy water. We might find that in trying to stretch our reality to see how it works, we simply unfold it entirely.
Keep questioning the X-rays, everyone. Keep looking for the invisible geometry in the spaces between the lines.